Answer scheme, sample question 1 with outline sample answers in red. Credit will be given for adding relevant labeled diagrams where these illustrate the answers. Question. Discuss, in a few sentences, what measurement is and why measurement techniques are important for industry today, in the UK and internationally. Answer. Measurement is the assignment of numbers or other symbols by an objective, empirical process to attributes of objects or events of the real world, in such a way as to describe them. It is the description of properties of objects or events, and not of the objects or events. The numbers assigned to a property by measurement must, within the limits of error, be independent of the observer. Measurement techniques reflect an empirical process. This means that it must be the result of observation and not, for example, of a thought experiment. Further, the concept of the property measured must be based on empirical relations. They can be reasoned in formal systems such as mathematics. Reliable, reproducible measurement and measurement techniques are vital for international trade. Question. Give an illustrative example of your choice of the use of measurement techniques by industry today. A wide choice is possible and illustrations from any industry form an acceptable answer. Question. The figure below shows a Rolls Royce jet engine, with a number of the important measurement points on the engine shown. Why is accurate measurement of these parameters so important for efficient running of an engine of type? 12 marks. Answer. Accurate measurement is important in this jet engine to ensure safety, good fuel economy, long life, and this is coupled to regular maintenance. Students can select any one or more of the measurements illustrated and discuss why accurate measurement of these parameters so important for efficient running of an engine of type. Sample question 2. Question. Discuss briefly the origin of the metric system of measurement and indicate why it is important for international trade. Answer. Metric system, international decimal system of weights and measures, based on the meter, m, for length and the kilogram, for mass, first adopted in France in 1795. Originally, all other metric units were derived from the meter, including the gram, g, for weight, 1 cubic centimeter of water at its maximum density, and the liter, L, or L, for capacity, 0.001 cum. In the 20th century, the metric system became the basis for the international system of units, which is now used officially almost worldwide. Question. Discuss, in a number of bullet points, why high-quality measurement vital for good data analysis. Answer. If we could not measure, we could not observe the world around us. Observing the world helps us to, at least in part, control our environment. Without measurement, we cannot create the control systems we need. We require good measurement for our control systems. Measurement allows us to record the past, and by doing so uncover patterns for the future. All engineering depends on good measurements being employed for both safety and most effective therapy. Measurement has made the world that we live in. Question. Give several reasons why accurate measurement is important in industry today and discuss what it enables the engineer to do. Answer. Accurate measurement enables us to maintain quality control during production processes, comply with and enforce laws and regulations, undertake research and development, calibrate instruments and achieve traceability. Question. The diagram below illustrates the generalized process of measurement. Discuss how this is implemented with a common measurement outside the laboratory, the measurement of temperature, e.g. of a patient in a hospital or clinic or of a room to make it comfortable in which to work. 5 marks. Answer. We want to know the temperature of something, e.g. a patient or a room. Step 1. We measure the temperature with a thermometer. Step 2. We use that information to determine if it is too hot or too cold. Create knowledge. Step 3. We act on that knowledge, propose a course of treatment for the patient, or we turn the heater, air conditioner, on or the heater, air conditioner, off. If monitoring a room overall, we make the environment better for ourselves and optimize our use and cost of energy. Sample question 3. What is the Internet of Things, IoT? and why are high-quality sensors and measurement systems important for the correct functioning of the IoT? 6 marks. Answer. The Internet of Things, IoT, describes physical objects, or groups of such objects, with sensors, processing ability, software, and other technologies. They connect and exchange data with other devices and systems over the Internet or other communications networks. The field has evolved due to the convergence of multiple technologies, including ubiquitous computing, commodity sensors, increasingly powerful embedded systems, and machine learning. Traditional fields of embedded systems, wireless sensor networks, control systems, automation, including home and building automation, independently and collectively enable the Internet of Things question. It is likely that self-driving cars, autonomous vehicles, will soon be available for wider use. Discuss the use and importance of IoT sensors, IoT connectivity, and innovative software algorithms as we move towards self-driving cars on our roads. 6 marks. Answer. Self-driving cars are only possible today due to the existence of 3 technologies. IoT sensors. Sensors for blind spot monitoring, forward collision warning, radar, camera, LiDAR, and ultrasonic all work together to make navigation of a self-driving car possible. IoT connectivity. Self-driving cars use cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditions, among others, to monitor their surroundings better and make informed decisions. Self-driving cars must be connected to the Internet even if edge computing hardware can solve small computing tasks locally. Software algorithms. All the data the car collects needs to be analyzed to determine the best course of action, the most complex part of the self-driving car since it has to make decisions flawlessly. Question. What is a smart city? Discuss the way sensors and connectivity are vital to the wider development of smart cities across the world. 8 marks. Answer. A smart city is a technologically modern urban area that uses different types of electronic methods and sensors to collect specific data. Information gained from that data is used to manage assets, resources, and services efficiently. In return, those data are used to improve operations across the city. Many different, yet interlinked characteristics all depend on excellent, dependable sensor systems. Sample question 4. Discuss what is meant by smart healthcare and describe the key components of a smart healthcare system. Discuss how they are interlinked by information flow. 5 marks. Answer. Smart healthcare is a health service system that uses technology such as wearable devices, IoT, and mobile internet to dynamically access information, connect people, materials, and institutions related to healthcare, actively manages and responds to medical ecosystem needs in an intelligent manner. Key components of a smart healthcare system. Question. The U.S. Space Agency, NASA, is known to value advanced measurement as key to success of its missions. Discuss briefly the reasons for that and illustrate briefly how advanced sensors are used by NASA to achieve its mission. 5 marks. Answer. Measurement systems are vital to the success of advanced engineering of this type. Many sensor systems in the rocket and the capsule to measure a wide range of parameters. Sensors used to understand how space medicine issues, minimize risk to astronauts during spaceflight. During testing before manned flight, 3 mannequins with sensors will be placed inside the rocket's capsule to measure radiation and vibration. NASA is developing several sensor systems and algorithms for use on Artemis moon landing. Safe and precise landing, integrated capabilities. Evolution, splice, technology suite. 3 primary elements, an inertial measurement unit, IMU, and a camera for terrain relative navigation, Doppler LiDAR to determine the lander's velocity and altitude, hazard detection LiDAR to scan the surface to create a 3D map of the landing field. This can be seen as the spacecraft equivalent to an autonomous automobile. Question. Discuss how NASA uses advanced systems in instrumented mannequins, dummies. Instrumented with sensors, to understand effects on humans of space travel, including exposure to radiation in space. 5 marks. Answer. Rather than astronauts, a mannequin named Commander Munikin Campos will helm the Orion spacecraft, with 2 mannequin torsos called Helga and Soho along for the ride. The mannequin, sporting the Orion Crew Survival System suit, can collect data on what future human crews might experience. Both phantoms are made of materials that mimic the soft tissue, organs, and bones of a woman. Their epoxy resin forms even resemble human lung and brain tissue. To test how radiation passes through the human body, the torsos have more than 5,600 sensors and 34 radiation detectors to measure how much radiation exposure occurs within different organs during the mission. What is climate change and why is advanced measurement important to understand climate change better and to deal with its effects on life on this planet? 5 marks. Answer. Climate change refers to a large-scale, long-term shift in the planet's weather patterns and average temperatures. Climate change is the long-term shift in average weather patterns across the world. Since the mid-1800s, humans have contributed to the release of carbon dioxide and other greenhouse gases into the air. This causes global temperatures to rise, resulting in long-term changes to the climate. We would not be able to quantify climate change without effective techniques in measurement,